Hello students, in today's class we will discuss about the function tan inverse x. So our today's agenda is, first we will discuss about domain and range of tan inverse x, then graph of tan inverse x, properties of tan inverse x, and after that we will solve the problem that says express tan inverse cos x by 1 minus sin x, where x is in between pi by 2 to 3 pi by 2 in its simplest form. So we will start with the domain and range of tan inverse x. Now we know that tan inverse x is the inverse function of tan x. So in order to find the domain and range of tan inverse x, first we will find the domain and range of tan x. Why? Because we know that if f a to b is a bijective function, then f inverse exists and f inverse is defined from b to a. That is, the domain of f is the range of f inverse and the range of f is the domain of f inverse. So what is the domain of tan x? Domain of tan x is equals to x belongs to R such that x is not equal to 2n plus 1 into pi by 2, where n belongs to z. That is, from the set of real numbers, we subtract the set where the points are of the form 2n plus 1 into pi by 2, where n belongs to z. So why we are excluding this point? Because in these points cos x is equals to 0, and we know that tan x is equals to sin x by cos x. So in these points, the points of the form 2n plus 1 into pi by 2, where n belongs to z, tan x is not defined. So from the domain of tan x, we exclude the points. And the range of tan x is equals to the set of whole real numbers. But now the domain that we have defined, the tan x is not bijective in this domain. Tan x is bijective if it is restricted to the intervals minus 3 pi by 2 to minus pi by 2, or minus pi by 2 to pi by 2, or pi by 2 to 3 pi by 2, and so on. In order to make tan x a bijective function, we generally consider the domain of tan x is minus pi by 2 to pi by 2, and the range is the set of all real numbers. Therefore, tan inverse is defined from the set of all real numbers to the open interval minus pi by 2 to pi by 2. Therefore, the domain of tan inverse x is equals to R, the set of all real numbers, and range is equals to the open interval minus pi by 2 to pi by 2. Now we discuss about the graph of tan inverse x. So suppose this line is y equal to pi by 2 and this line is y equal to minus pi by 2. So tan inverse x is defined for all real numbers and it takes the values between minus pi by 2 to pi by 2. So the graph of tan inverse x is something like this. This is our y-axis and this is our x-axis. Now we will discuss some important properties of tan inverse x. So the first property says tan inverse of tan x is equals to x, where x is belongs to minus pi by 2 to pi by 2. The second property says tan of tan inverse x is equals to x, where x belongs to R. Then the third property is tan inverse of minus x is equals to minus of tan of x. The fourth property says tan inverse of 1 is equals to cot inverse x for x greater than 0, and it is equals to minus pi plus cot inverse x for x less than 0. The property 5 is tan inverse x plus cot inverse x is equals to pi by 2 for all x belongs to R. Property 6 says tan inverse x plus tan inverse y is equals to tan inverse x plus y divided by 1 minus xy, where xy is less than 1, and also tan inverse x minus tan inverse y is equals to tan inverse x minus y divided by 1 plus xy, where xy is greater than minus 1. And then property 7 is 2 tan inverse x is equals to tan inverse 2x by 1 minus x square, and also we have 2 tan inverse x is equals to sin inverse 2x divided by 1 plus x square, where mod x is less than equals to 1, and 2 tan inverse x is equals to cos inverse 1 minus x square divided by 1 plus x square, where x is greater than is equals to 0, and also we have 3 tan inverse x is equals to tan inverse 3x minus x cube divided by 1 minus 3x square. Now we solve the given problem, that is we simplify the expression tan inverse cos x divided by 1 minus sin x in the interval where the interval is given pi by 2 is less than x is less than 3 pi by 2. No, so why we can define this expression? Because the expression cos x by 1 minus sin x, say y, this is a real number. This y is a real number because 1 minus sin x is not equals to 0 in this given interval. And since this cos x by 1 minus sin x belongs to R, therefore there is no harm to define the expression tan inverse cos x by 1 minus sin x. So first we will try to write the expression y in the form of tan. So first write cos x is equals to sin pi by 2 minus x, that is sin pi minus 2x by 2. Then write sin x is equals to cos pi by 2 minus x, that is cos pi minus 2x by 2. So our y becomes sin pi minus 2x by 2 divided by 1 minus cos pi minus 2x by 2. Now we have a formula that sin 2x is equals to 2 sin x cos x. So in this formula our numerator sin pi minus 2x by 2 becomes 2 sin pi minus 2x by 4 into cos pi minus 2x by 4. Also we have a formula that says 1 minus cos 2x is equals to 2 sin square x. So in this formula 1 minus cos pi minus 2x by 2 becomes 2 sin square pi minus 2x by 4. So our expression y becomes 2 sin pi minus 2x by 4 into cos pi minus 2x by 4 divided by 2 sin square pi minus 2x by 4. Now we will divide the numerator and denominator by sin pi minus 2x by 4. We can do this because sine pi minus 2x by 4 is not equals to 0 in the given interval. So our y becomes 2 will also get cancelled out. So cos pi minus 2x by 4 divided by sine pi minus 2x by 4. So that is cot pi minus 2x by 4. We know that cot x is equals to tan pi by 2 minus x. So we write the expression y equal to tan pi by 2 minus pi minus 2x by 4. So it becomes tan, LCM is 4, 2 pi minus pi plus 2x. So that is equals to tan pi plus 2x by 4. So it becomes tan pi by 4 plus x by 2. So our expression tan inverse cos x divided by 1 minus sin x reduces to tan inverse tan pi by 4 plus x by 2. Now we know that tan inverse tan of x is equals to x. That is a property we discussed. So our expression reduces to pi by 4 plus x by 2. Hence tan inverse cos x divided by 1 minus sin x is simplified as pi by 4 plus x by 2. So this is our required answer. So students, I just remembered that I made a mistake in this property, that property 3. So in this property it will be tan inverse of minus x equals to minus tan inverse of x. It will be not be tan x, it will be minus tan inverse of x. So sorry for the mistake and thank you.